Hello everyone. Hope you guys are doing good. At last I got some time to upload a new video uh, about Kubernetes. So I thought to take a class about Kubernetes, and this will take 3 weeks. I have planned to cover Linux also. Linux topics will come 40 to 50 percentage Linux topics, and then Docker basics, and then we'll quickly move into the Kubernetes core concept. First, we need to understand the cloud vendors and all how they are offering the Kubernetes service. In Azure, they are calling as AKS. Google Cloud, they are calling as GKS, and Amazon, they are calling as EKS. Red Hat, it's OpenShift. Uh, so, so here there will be no much difference on the core Kubernetes topics. Here and there will be some infra level changes. Again, it depends on your cloud vendor. So here in our demo session, we are going to see the Azure Kubernetes topics. So during the lab session, we are going to see the core Kubernetes topics. With that knowledge, you can manage any cloud Kubernetes service. I'm sure about that. And who can learn Kubernetes? As a fresher, you can learn a Kubernetes platform. And then developers, yeah, you are good with the code, but you are not good with but you are not familiar with the infra side. So it is a right time to grab this opportunity and to enhance your skill. And then a system admin profile, whoever is working as a Windows administrator or Linux administrator, it's a evolving platform. It's the right time to enhance your skill, as I told you earlier. So so whoever is working on this profile, you guys can learn a Kubernetes very well. Okay, let's quickly jump into our demo session. Okay, what is Kubernetes? Kubernetes is a rapidly evolving platform that manages container-based application and their associated networking and storage components. The focus is on the application workloads, not the underlying infrastructure components. This is a key point here. The Kubernetes provides a declarative approach to deployment backed by a robust set of API for management operation. In Kubernetes, the API server is more powerful. You can build and run modern portable microservice based application that benefit from Kubernetes orchestrating and managing the availability of those application components. Kubernetes supports both stateless and stateful applications. As team progress through the adoption of microservice based applications. Benefits of containers. It's less overhead. Containers require less system resource than traditional or hardware virtualized environment because they don't include any operating system images. They don't include any kernel libraries. First, we need to understand that. See, the container is not a OS. It is not a complete OS. It doesn't contain any kernel related libraries. So the container contains only the application related libraries along with, if you want any other libraries which we are using in day-to-day operations, we can install those libraries during a build. So post build, if you are installing any libraries on top of container, that is not persistent. If the container got reinitialized, all those changes gone away. So this will obviously give a portability with a more consistent operation and also the greater efficiency. So it is good for the better application developments. Okay, let's take a look at why Kubernetes is so useful by going back in time. So if you see the traditional deployment, we have a hardware. On top of hardware, we are installing OS. On top of OS, we are installing our required applications. And then we are moving to the virtualized deployment. The virtualized deployment also, it's a pretty same, but on top of OS we are installing a software called hypervisor. So that is giving a capable to install customized OS. This OS could be any OS. It could be a CentOS, it could be a Unix flavors, whatever it is. So we are now moving to the container deployment. So what is the change in the container deployments? So this is pretty much same as a virtualized deployment, but the change is like rather than installing hypervisor, we are installing a software called container runtime. So the container runtime, it's we have the daemon. It might be a Docker or it might be a container D. But recently we have found, I mean, the Kubernetes team found that there was an performance deviation if you are using a Docker. That's why I think most of the cloud vendor also removed the Docker daemon and they are putting a container D now. So on this is giving a capable to run a instance, container instance on top of your container runtime. So that is our container. Okay, this is a Kubernetes cluster architecture on AKS. Okay, this is I have taken from the official Microsoft site. Okay, and we'll see one by one. If you see there are two square box, like one is the master node and the right side is the worker node. So the worker node only we are going to deploy all our applications, and the master node having the cluster related informations like API, schedulers, control manager, etc, and we'll see what is the use of all those components. The Kubernetes cluster is divided into two components. One is master node and the other one is the worker node. So when you create a AKS cluster, a control plane is automatically created and configured. This control plane is provided as a managed Azure resource abstracted from the user. So there is no cost for the master node. Only you are going to pay whatever the worker node you are using, whatever the worker node and whatever the other resources like network, storage, etc. Kube API server. The API server is how the underlying Kubernetes APIs are exposed. This component provides the interaction for management tools such as kubectl or the Kubernetes dashboard. etc is a kind of a database, I can say, to maintain the state of your cluster and configurations. The highly available etc is a key value store within a Kubernetes cluster. Kube scheduler. When you create or scale application, the scheduler determines what nodes can run the worker nodes, what nodes can run the workload and starts them. Okay, and Kube controller manager. The controller manager oversees a number of smaller controllers that perform actions such as replicating pods and handling node operations. So these are the primary components in the master node. In Kubernetes, we have a types of controllers. One is a node controller. It is responsible for noticing and responding when nodes goes down. A replication controller, it maintains the number of pods. It controls how many identical copies of a pod should be running somewhere on the cluster. An endpoint controller is nothing but to join a service and pods together. Services account and token controller handle the access management, and the replica set controller ensures the number of replications of pods running at all time. Deployment controller provides a declarative updates of for pods and the replica sets. Daemonset controller. So Daemonset controller, it will require some special use case like a monitoring or ingress and all. We need to deploy as a Daemonset so that it will deploy all the pods for all the running worker nodes. That is the work behavior of the Daemonset. And then the job controllers, it's we are aware of if anyone is more familiar with the Linux, they might aware of that job. I'm not sure what it is, the terminology which is using in the Windows. Cron tab, right? Same like in Kubernetes, we can run cron also in Kubernetes. So that kind of functionality which is giving for the job controller is a supervisor process of for pod and carrying out batch jobs. And service allow the communications. That's it. In Kubernetes, there is a concept called services. If you remember in the earlier slide, we have seen types of controllers. It's a part of that. The service will allow communications. So by using a services, what we can achieve. So what types of services, what it will do, what was the behavior of all those three services, for what type of scenario we can use these different types of services. So to simplify the network configuration for application workloads, Kubernetes uses services to logically group a set of pods together and provide network connectivity. Cluster IP. So if you are defining your deployment or a service as a cluster IP, so that will create an internal IP address for your service. So that will, by using that, you can communicate within your cluster. You can expose your application within your cluster. That is the cluster IP. If you didn't specify anything on your service, so by default that will consider as a cluster IP. And then node port. Uh, in node port, it's in production environment, I'm sure no one will prefer the node port. This is just for testing purpose and in a lab session, especially for the tutorial and all. Node port will be preferable, since when you browse the site, for example example.com :8080 or 8081, that is weird, right? It's very difficult to remember the port number and all. So in practical, uh, it's very difficult to manage. It's very difficult to remember all the port numbers and all. So it's a type of service. We need to understand how it works. So if you see here 31000, so that is the port range actually. I'm not sure the exact port range, but this will start from 3 lakh something only. So within that range only, this node port will create it. And if you want to create a designated port number also, you can create it within that range. That is a work behavior of the node port. You can also expose the outside the world by using the node port with the respective port number. And what is the use of load balancer? Load balance, create the Azure load balancer resource configures an external IP address and connect the requested pods to the load balancer backend pool to allow customer traffic to reach the application. Load balancing rules are created on the desired ports. So when you create a service as a load balancer, that will create a external public IPs. Okay, by using that external public IP, you can expose the application outside the world. But moreover, people won't prefer the load balancer in a production environment, since so for that only, Ingress will comes into the picture. Why load balancer is not useful? Why people are preferring Ingress? We may have a question, right? So because the L4 is not that much of intelligence to compare the Ingress, and other than that, it has a very less features, I can say. And this will act as a load balancer. I mean, OSI model, L4 L7 is there, so this will work with L4 model, and the Ingress will work with the L7 model. So that is why the Ingress having a capable to route the request properly, and then it also having the SSL termination and SSL cert key and all, you can able to pass by using Ingress. So that is the work behavior of the load balancers. Once you have created as a load balancer, as I told, it will create a public IP. By using that public IP, you can expose the application outside the world. But again, for still few cases, you can create a load balancer, especially for the SFTP and all. You can create a load balancer that is, for SFTP and all, you didn't route any request, right? You're just uploading some files in it. So for that type of scenario, you can use the load balancer. Okay, load balancer we have seen, and then now the topic is Ingress Controller. So as I told earlier, the load balancer only work at layer 4, but the Ingress will work at layer 7. So that is why it's more intelligent to route the traffic in a efficient way. And also, it has a SSL and TLS termination. You can able to feed all your cert and key information in your Ingress deployment file. So the Ingress, I can say the Ingress will act as a smart router. It's not a service. This will act as a smart router. So once you have configured Ingress, you can see the public IP of the Ingress. In Ingress configuration file, you just need to mention your deployment service name. So that is why the Ingress will look at your resources, what you are giving, what service you are giving, and that will pick up your application, and then it will expose outside the world. So we have a different type of ingress in market. Kubernetes having a native ingress. Nginx ingress is more popular. Most of them, I think 60 to 70% of people are using Nginx ingress controller. And Azure having a native ingress called application gateway ingress. But this is a paid one, that is a different. And other than that, the application gateway ingress giving a better performance. Recently, I have gone through some article in Azure. They have made some test with comparison between the Nginx ingress controller and the application gateway ingress controller. So the application gateway ingress controller giving a better performance than the Nginx ingress controller, since the design would be it's quite differ. That and all we can see in our practical session how it works, what was the different in it and all. And other ingress like a traffic, and I think HTO also having some kind of ingress. So this is ingress. That's all about the ingress. The next one is Azure Virtual Networks. In a case, you can deploy a cluster that use one of the following two networks, either Kubernetes networks or the Azure CNI, Azure Container Network Interface. And also AKs will give you some leverage to use the Calico. It's open source, but you should be familiar with all the network stuff. So this is the architecture of the Azure CNI network, how it works, how it is interlinking with your Azure virtual networks and the pods and all. So if you have any issue with the Azure networks, you can log a case with the Azure team and you will get it shot out. But if you the Calico and all, it should be our responsible to take care everything. So if you are using the Kubernetes basic networking and all, there was some limits in the IP sets and all, and also there was a performance would be a differ here and there, and you will obviously you need to go Azure CNI networking for the production setup. The next one is a namespace. In Kubernetes, the namespace is something like isolating a space, and from there you can deploy your application. For example, if you have a number of clients and you are running on a single cluster, how it possible means you can create a namespace for each and every customers or client, and within that namespace you need to deploy all your deployments, like either it could be a deployment or Statefulset service secret, whatever it is. You need to create a dedicated namespace to the particular customer, and within that namespace you need to create your deployment. So in all your deployment code you need to mention the namespace name of the customer, so that all the deployments will be deployed on that namespace. That is the concept of the namespace. So here they are giving a small example and understanding of the namespace. That's it. Okay, the next one is, it's a very interesting topic, horizontal pod autoscaler. So the Kubernetes uses the horizontal pod autoscaler to monitor the resource demand and automatically scale the number of replicas. By default, the horizontal pod autoscaler checks the metrics API every 30 seconds for any required changes in replica count. When changes are required, the number of replicas is increased or decreased accordingly. The horizontal pod autoscaler works with AKS clusters that have deployed the metric servers for Kubernetes 1.8 after versions. When you configure the horizontal pod autoscaler for a given deployment, you need to define the minimum number of replicas and maximum number of replicas, and also you need to mention the CPU utilization, like average or value. You need to mention the threshold limit of the CPU usage and the memory usage. So it depend upon the configuration. So whenever your deployment getting a spike, whenever you for example, if you are setting the CPU limit is 70%, if you're running with a single replicas, and your HPA you are mentioning like after 70%, I need these number of replicas. Example 5, I need a max 5 replicas once it crosses 70% of the threshold. So first it will look at the running replicas threshold, and once it got overutilized, then it will scale up the maximum number of replicas what you have defined in the horizontal pod autoscaler. So here you will get a scalable option as well as the load balancer option, and this is one of the beauty of the Kubernetes cluster. It will giving a both feature in it. Okay, this is a cluster level autoscaler. So the earliest slide we have gone through the how the HPA will works. So that is for within a cluster. Inside the cluster, we are getting a scalable option when we are getting a load balancer option to balance your workloads. But from the cluster level, what is the cluster autoscaler means? And this is this will closely intact with your HPA, because whenever your pod will getting spike, and you will get a new pods, you will get a maximum number of pods whatever you have defined in the HPA, right? So during the time, the cluster will see whether you have enough node pools, then it fine. There will be no issue on that. If you don't have enough node pools, if you don't have enough VM in your cluster node pools, then the cluster will recognize, so there will be a shortage on the node pools. So the cluster will bring you the new VMs into the node pool, and then your deployment will be assigned to that new node, and you will get the application. It's up and running fine without any deviation or any downtime. So that is the beauty of the cluster autoscaler. Okay, this is a storage. So how we are integrate the storage into the Kubernetes clusters. So before that, we need to understand the types of Kubernetes volumes. So I have listed out the volume types, and also if you see this point number 2, cloud volumes, each and every cloud vendors, they have a own uh, uh, disks and all. Like the GC is calling a GC persistent disk, and AWS is using AWS Elastic Block Store, and Azure is using Azure Disk Volume. So even by using that, you have a different kind of you need to create a storage provisioner. You need to create a storage class first, and then you should make sure that you have a right access to create that particular disk, and then you can create a PV or a PVC. uh, First, you need to set up your pre-request before creating a PV and PVC, and then you can create a persistent volume, and you need to mention all those volume details into your deployment file, so that it will uh, attach to your pod whenever the pod will get reinitialized or will get started. So here is a picture, the how it is um, how it is connected, interlinked with the physical storage. Okay, here is the course content I have given for the Kubernetes topics. The prerequisite is, first we need to create a lab setup. One is we need to create in your local machine with the Minikube, and other setup we need to create in a Google Cloud that is more flexible to work and explore all other features in Kubernetes. So I will prefer a Google Cloud, and then we can see the basics of Linux. If you're already good with the Linux, it would be fine, not an issue. Um, if it is something new to Linux, I will try to cover 50 to 60% of the Linux topics and the basics of Docker. And then we'll quickly move into the Kubernetes topics. We'll see what is pod, how we can create a simple pod, and then we can create a deployment stateful set. What will be the difference between the deployment and stateful set? What kind of application we can create in a deployment, and what kind of application we can create in a stateful set. And then we can see what is Daemonset, Ingress, services, and especially this persistent volume and all we can explore in the Google Cloud. Persistent volume, Ingress and all we can play around with the Google Cloud, how it works. Uh, and then RBAC, it's a role-based access control, and this is giving a limited access to your internal team, how we can do that. And then in the earlier slide, we have gone through the HPA. but in practical, how it works, we need to initiate a load on your deployment, and we'll see how it got replicated, how it got scaled up. And then config map, we'll see how the config map will work, and we'll see how the secrets and will work. And we need to collate all the Kubernetes topics, and we need to create a single deployment. Like point number 4 to 13, we are collating all this topic and we are creating a single deployment, and we'll see how it works. So these are the areas we are going to focus on our lab session. Okay, thanks for watching. And if you guys interested to learn Kubernetes, Azure Kubernetes, and you can drop a mail to the given mail ID, and that is staytune666@gmail.com, and we can connect depend upon our availability, and we can go through all the course content. All right, see you.